The main goal of our project was to build a machine learning model that could accurately predict stock prices and could be used to generate a profit. We used a long short-term memory architecture to take 30-day windows of stock closing prices and then predict the following day's closing price. We also used the Reddit API to pull data from 2025, and then we used the Llama 3 open source large language model to classify what tickers were being referred to in the posts. And then we used the Yahoo Finance API to get the actual closing prices for a 5-year period. Uh, we ended up also creating an algorithm for the machine learning model, which uh, decided whether or not the model would buy or sell. Basically, when the model predicted the price would go up, then the algorithm would buy, and when it predicted it would go down, it would sell. And we also had a control strategy, which basically randomly decided to buy or sell. And after doing a comparison between these two strategies, we found that our machine learning model barely outperformed the random strategy. And this is likely because past performances in the market do not necessarily indicate the future stock prices. There were several major limitations for this project. The first main one was the Reddit API. Since we had to collect so much data, we were often hitting usage limits, and that made it so that we could only get Reddit posts in 2025, and this severely limited the sentiment analysis part of our project, and we ended up having to cut it from the final build. Um, we did have the data for the 5 years, the closing price data. However, we weren't able to get the corresponding sentiment analysis data, so we ended up only comparing it to the random strategy. Another major issue was the Llama 3 model was only around 60% accurate, um, classifying the stock tickers for posts. We used several different prompt engineering tactics as well as different models, but none of them were super accurate. Another issue was that towards the end of the project, the Yahoo Finance API stopped working for the entire team, which severely limited the progress we were able to make towards the end. In addition, the model evaluation requires a lot more user interaction because they have to manually upload CSV files with corresponding stock data because Yahoo Finance doesn't work.
In this notebook, we collect initial data from the Reddit Wall Street Bets subreddit. Setup, we use the PRA Python extension, which enables us to more easily use the Reddit Data API. Here we load some important environmental variables, which you can include in a .env at the root of this project. With this connection, we access Reddit data for submission posts where users of Wall Street Bets discuss personal finance information and personal investments. With the free version of the Reddit Data API, data collection is limited and resource intensive. Thus, we supplement data collection by downloading a more convenient Kaggle dataset, which has already been collected, and unifying it with the pre-existing data. In this notebook, we update our collection of Reddit data with sentiment analysis scores. We begin by uploading the specific packages, including NLTK, that is the Python package for Natural Language Toolkit. We also download with a specific download directory certain packages and corpuses that we may need in the process. Then we read in our previously collected Reddit data and clean per testing against a pre-made schema to verify types. Then we clean stop words and remove special characters from the corpus. and specifically our Reddit data text, which are very small sentences. Then we use the natural language toolkit, specifically this sentiment analysis functionality, to provide sentiment scores, positive, negative, neutral, and a combined score for each Reddit data element.
So before I began pre-processing the stock ticker data, I performed some exploratory data analysis. This involved using the Apple stock ticker to test the Yahoo Finance API, and I discovered that the API returns the closing, high, low, and open prices, as well as the stock volume. I also plotted the closing price to make sure that the data could be used for prediction. So I ended up downloading the 70 billion parameter open source Llama LLM to take the collected Reddit posts and convert them into the stock ticker that the post is referring to. And so basically you have to add the updated tickers text file to the Google Colab environment, and then it will automatically be added to a Python list. And then a data frame with all the data connected to these tickers is created. So because stock tickers can have very different prices, we perform some data normalization. So this involved using a min-max scaler to scale the stock data between 0 and 1. So we decided to use a LSTM model architecture for this project, and LSTM models take a very specific data shape. So basically what we had to do was set up a 30-day sliding window, which would be used to predict the next day after that 30-day window, and that would be the actual stock price. And basically we pass this 30-day window through all of the stock tickers' closing prices. After conducting some research, we discovered that the closing price is the best way to predict the stock. And here you can see basically these 30-day sliding windows are stacked on top of each other, and then there's the corresponding actual value, which only has a dimension of 1. And for our data split, we decided that the training and validation should be 90% of the data, and then the test set would be the remaining 10%. And between the 90%, 85% of it is training data, and then 15% of it is validation. The model architecture that we decided on for this project was long short-term memory, because it's very good at finding connections in sequential data, which was perfect for stocks, which the day after a 30-day period is very closely correlated to that sequential data. So we had 2 layers that used LSTM architecture, and then we also finished the model by having multiple dense layers at the end. And this was so that the model could learn additional nonlinear patterns. We also had an output of a single neuron, because we decided that this should be a regression problem where it outputs a normalized value for the stock instead of just classifying whether it goes up or down. And we used the Atom optimizer with a learning rate of 0.001, and our loss was mean squared error. So as you can see, we did our best to reduce the overfitting and underfitting of our model. And then we used the test set, and you can see here it actually gets the general gist of what the output should look like. Although it's not perfect, it did have some very good results. We had a mean absolute error of 17 on the test set, which means our model is only off by an average of $17. Something that I failed to mention in the previous notebook is that we yielded an R-squared value of 0.7874, which means that 78.74 of the variance in the stock price is explained by our machine learning model. Unfortunately, when we were working on the model evaluation notebook, the Yahoo Finance API broke for the entire team. Therefore, we had to use a separate API, and we loaded its results into CSV files that can be added to the Google Colab runtime environment. And we used 10 different stocks that were not in the training or validation sets to evaluate our model. Luckily, before the Yahoo Finance API broke, we had saved our machine learning model as a H5 file. Therefore, it's very easy to load into this new notebook. So the format that is accepted by the LSTM model is the 30-day windows. Therefore, our data has to be pre-processed in the same way it was for the training, validation, and test sets in the previous notebook. So we developed an algorithm that could be used for both the machine learning model as well as the random trading strategy. For the LSTM model, basically it makes a prediction based on the 30-day window, and then it looks at the price from the very last entry in that 30-day window. If the prediction is greater than the price at the end of the window, then it will buy $100 of the stock. However, if it is less than the baseline price, then it will sell the stock. And basically, selling the stock means it will go through all the selling prices from its previously bought stock, and it will remove one of them and sell it at the discounted price to curb the loss. And then finally, all the stock that the model has bought throughout this process is finally sold at the very last day. So that means that the profit is only based on the last day of our data. And you can see here for each stock, it shows how much the model decided to buy, how much it decided to keep, and also what prices it bought it at, and what the selling price was when it did actually sell the stock. And then the overall results were that it lost about $100. And this is something that we were kind of expecting from the beginning because it's really hard to actually make money in the stock market with machine learning models. And then for the random strategy, the algorithm is essentially the same. However, at every window, a random number is generated, either 0, 1, or 2. And basically, it will either buy, sell, or do nothing randomly. So unlike the LSTM model, it also chooses the stock that it's going to sell at random because it doesn't have any prediction price to compare to the buy prices that have already been added. And basically, the results for this show that it performs significantly worse than the LSTM. On average, we're seeing around $700 difference between the two strategies. So a quick update to what you just saw. We transitioned from using the CSV files to using Yahoo Finance because it started working again. We also fixed some bugs with the algorithm logic. First of all, the stocks were being sold at the prediction price instead of the baseline price, and we also had some issues with how we were calculating the percentage change. We also increased the increments from $100 to $200. The reason we did this is because the model only has a short 210-day window to buy and sell stocks, and this is because we didn't want any conflicts with the training or validation sets. And after evaluating the model, we found that it now breaks even. This means that our model is accurately predicting the stock prices. And then we made the same updates to the random behavior logic, and now it loses a lot less money than it did before, but it is still outperformed by the LSTM model. We also added a third paper trading method, which used the sentiment analysis that we gathered earlier in the project. We iterated over all the test stock tickers, and we averaged all the post sentiments. We looked at the averages for both the positive and negative sentiments. After that, we iterated over the stocks again, and then we looked at how much the positive contributed to the total and how much the negative sentiment contributed to the total, and we got the percentages for these. And as you can see here, the positive is a lot more prevalent than the negative sentiment, and this, we think, influences some of the results. We use the same logic as the random behavior, except now it uses the sentiment percentages instead of the equal distribution that was used for the random behavior. We also added a 1% chance of the model doing nothing. This is because the LSTM model, it would not do anything if the prediction price equals the baseline price. However, this is very rare, so we left this as a low percentage to be able to directly compare the results. And we found that this model performs worse than both the random behavior and the LSTM model. We think it's because the positive sentiment is causing the model to buy more often than it sells. And at the end of the 210-day period, when it is liquidating, it's selling at a lower price than when it bought. And this goes to show that just using the sentiment for Reddit posts is not a very good way to trade stocks.